as this webinar goes and as SRS rolls this out. So with that, I'd like to turn it back over to Brian.
Thank you, Michael. So let me make a few points about today's agenda, and then we'll get underway. First thing we wanted to spend a few minutes is discussing the key barriers to energy efficiency project sales. I think these will be familiar themes to those of us on the call, but just to sort of calibrate the problem in the market as we've experienced it. As Michael said, principally we want to introduce you to a new technology and data tool today, which is referred to as EPIC, the Energy Performance Improvement Calculator. And we'll have some discussion about how that solution is designed, as Michael just described, to help with the challenge of selling energy efficiency projects. And the third core piece of the discussion will be how that solution is really designed to meet a property owner's investment underwriting or investment due diligence needs. And as Michael also just indicated, given the circumstances, economic circumstances, all our businesses are facing, and of course our prospective property owner businesses are facing, this investment underwriting and the scrutiny of the project economics would seem to only be heightened currently and certainly in the near future. So with that, I will start the discussion on the key barriers, or said differently, defining the problem. So again, I know this is likely to be a familiar theme to those on the call, but building owners can be tough customers, right? Typically, they're very reluctant, or the last thing they're seeking to do is to pull out the checkbook for an unwelcome or unscheduled HVAC equipment replacement project. Having said that, what they rarely see is the other side of the equation, meaning high efficiency equipment will typically generate 25 to 30% energy cost savings for years to come. Most of HVAC equipment, at least for 15, maybe upwards of 20 years. And that is a compelling benefit. Part of the problem has been many of the HVAC contracting firms have lacked the tools to estimate those energy cost savings and the related financial impacts to include in their project proposals and subsequently review with the property owner. On the energy efficiency project developer side, often those firms do have the core competency to do estimated energy savings. However, at the time of their first engagement or so-called first look with a property owner, the owner is often reluctant to make a financial commitment at that time that justifies the project development firm to put the at-risk staff resources on the project and to prepare a detailed energy audit to estimate those savings. Those of you in that sector would know wouldn't be uncommon to have a $10,000 to $20,000 investment to justify your work in that area. And again, at that early stage, the property owner is often reluctant to make the commitment before they have a good vision of what the economic impact of their project opportunity may be. So in sum, what's the result of this? Building owners often only are privy then to the information about the replacement cost. And given the usual posture of the building owner, if the equipment has not failed, they often will take the no action option, which is to say delay the decision to replace the equipment that clearly is beyond its useful life in most cases. And in many cases, the building owner will even freely admit that they're over-investing in the maintenance, but so be it. That sort of summarizes the problem. And given this market circumstance, we at SRS, who's Michael mentioned, we not only work here in the state of Rhode Island, but in many states around the country, and we collaborate with contracting and project development firms on a regular basis. We often hear this frustration from the contracting and project development audience of, why is it so tough sell energy efficiency projects. You know, it seems so intuitive, and financial savings opportunities are there, but yet it's always difficult to get the property owner to make those decisions with urgency. So our company background includes a long history in the commercial property space, specifically in the development of software, data, and analytic tools. And about 2 years ago, we began to apply those core competencies in our experience administering CPACE projects on a nationwide basis, and collaborating with the industry on meeting these project origination challenges. We set out to develop a tool to really address the challenges here and make this process a little easier. That led us to a multi-million-dollar investment that was really focused on first defining the problem. We've often heard about this notion of, you know, there's sort of a missing link in the process, right? Particularly in that preliminary scoping and project sales area. And we were really focused on developing a technology, software data analytics type solution. And we recognized that the tool would have to be easily accessible, meaning via an app. And our going in presumption was the criteria of success would be, even at a preliminary stage, the analytics would have to be technically sound so that a project developer would have the comfort to present it even in a preliminary scenario, and the property owner could have confidence in the key financial metrics. And of course, it would have to be an easy to use and affordable tool. That led us to a couple-year solution development process, which has recently culminated in a deployment of a solution. Again, it's branded EPIC for the Energy Performance Improvement Calculator, and this is a cloud-based app that with just minimal project data inputs. That's another challenge that we routinely heard from project development folks that were experienced with even, you know, sophisticated energy modeling softwares and tools. The challenge was, however, to deploy those tools in the preliminary stage of a project. It was very difficult, if not impossible, to collect the data that those tools require for inputs. So that was a principal part of the challenge that we were looking to solve. And in our mind, the tool would have to be able to instantly estimate the energy cost savings and the financial impacts to really meet the market need. Initially, where the tool was aimed is HVAC improvements, whole building energy management systems, and lighting equipment replacement projects, specifically like-for-like equipment projects in this sector. The other area, again, given our role in administering the CPACE projects on a nationwide basis, and here in Rhode Island, we recognize that a lot of the contracting and project development community doesn't come to the CPACE program with a deep experience with the utilization of third-party financing and preparing cash flow pro formas or projections that can be shared with a property owner. And of course, typically the property owner is a more finance-oriented stakeholder. So it was another area that I'll share with you we were focused on, and the EPIC tool does enable a real-time project pro forma that can integrate PACE financing. So that's an exciting new development in our sector for sure. So underlying EPIC is a series of databases. Some of this data is proprietary data that we have collected over about a decade worth of experience now in collaborating with firms over the country now. It's something on the order of 1,500 unique contracting and project development firms that we've collaborated with. And we've been refining these predictive analytics and the technology behind it over those years in our conduct of third-party technical reviews and project approvals for third-party PACE financing. And so the net of this is contractors and developers can now provide building owners with the project economic analysis that most building owners are seeking, to feel that they've checked their boxes in their underwriting and due diligence process and feel that they are fully informed to make such an investment decision. And again, our thinking is under our current environment, that scrutiny is going to be all the more challenging here in our near term. And so with that, I'm going to switch to an introduction of the application. And again, I would encourage any of your questions as we go via the chat box. So on my screen now is the Energy Performance Improvement Calculator, or the EPIC app. And when a user logs into the app, to the extent they have created in their property manager screen past projects, you'll see in my screen I have a number of past projects. And so at that point, the user can either go back into their property manager database and pull out a project that they've worked on in the past, or create a new one. And for purposes of our discussion this morning, I thought we would go through the process of creating a new property, which we'll do now. And I've selected a office building in Providence, 235 Plain Street, and you see once you start entering the address information, or if the building has a particular place name, the app will look it up. So that's first order of business, to enter a property address into the tool. You'll see then the EPIC will then calculate a latitude and longitude. That's an important piece of information for things like doing the weather normalization process and so forth that I'll speak to in a moment. The tool, as you see, does integrate Google Mapping, so you can ensure that it's properly located by the GIS technology. And as well, particularly if you're doing rooftop unit replacement, something of that sort, it does fully integrate the satellite imagery as well. So with that, we'll save the property in the system, and once the property is saved, it will then appear in your property manager queue, and you can access that property via the little power icon here on the edit project info. So we'll do just that. When you access the app, you'll see down the left-hand margin, there's a series of tabs. You can think of those as a left-hand navigational path, which we'll generally follow here throughout the discussion, starting with the building information. And again, we're working with the property that I just entered, 235 Plain Street in Providence. In some cases, the app does go out and it looks for public record data that may be available on a property. So in some cases, we'll be able to define from public record data the year that the property was constructed and the gross square footage. In this case, I see the system was not able to do that. So I did look that up, actually by way of a LoopNet posting on, generally on the web, and determined that this building was constructed in 1984, and it is approximately 35,000 square feet, 34,615 according to the records. And then, so I enter that data as building characteristics, and then my next action is to define the property type or its use. So I just wanted to share with you there. This tool can support both public and private buildings. You'll see the queue here, starting with the education or school categories, both university and and elementary and middle and high schools, the food sales category, food service, fitness, health club type facilities, healthcare, both inpatient care and outpatient care, the lodging industry, ranging from large resorts to small hotel or motels, multifamily apartments, office, and some of the other public assembly type buildings and public buildings, fire, police stations, concluding with retail from big box to strip center and warehouse and storage. So broad spectrum of property types that the tool will support both on the commercial building and the public building side. Our building is office, so we'll select the office category, and at that juncture, you'll see the app does a few things. Based on, again, the type of building and the size of the building and the geographic location, the underlying database will make an assumption on how is the building heated, in this case, natural gas, how is the building cooled, in this case, rooftop air conditioning units. So that's an assumption that's made on geography and the characteristics of the use and the size of the building. If that assumption is not correct, then let's say the building is cooled by a chiller plant, then just by making those toggles, the user could override that. So then the next thing that we're looking to do is to define what are the energy efficiency improvements or project types that the user has in mind in developing a project scenario or scenarios, plural. In our case, let's assume we're going to propose a rooftop air conditioning replacement, whole building energy management system, and let's say there's an LED lighting opportunity as well. And once I select those improvements, I hit the submit button. And once I hit the submit button, I'm going to go to the first the energy consumption screen and make a comment on one of the core overriding assumptions. So what EPIC is doing based on that location, property use, and property type and size is to create a peer building profile and go into an underlying database that we manage, and based on the assumption that the subject property operates similar to peer buildings, and peer buildings being defined as same property type, same size, in the same geographic market, which is to say subject to the same weather conditions, to make an estimate of the baseline electricity use and baseline natural gas use. You can see in this case, EPIC is estimating on an annual basis the kWh consumption is about 550,000 kWh per year. You'll see that the tool will then weather normalize those values, which will then be used in doing the next step, which is the weather normalization process by system end use. So here, those of you that are come at this market from an energy auditing point of view, you are likely familiar with using CBEX tools for energy end use estimation. That's the starting point here with the EPIC tool. We do utilize the CBEX database. We also enhance that data set through some of our proprietary project data, and also with a level of weather normalization that gets closer to the subject property. Again, those of you that are familiar with CBEX are likely familiar. It's a fairly broad use of regions per se. So that allows, of course, in our project, if you recall, we were one of our components is air conditioning. So of course, it's important to know the whole building assumed consumption. It's even more important in that particular measure to know the cooling system estimation, which you see about 72,000 kWh per year, or about 13% of the whole building consumption. And again, those values are editable if the user happens to know differently. Maybe you've already conducted a site visit and have insight. As a, for instance, maybe you've done a site visit and you see that approximately 8.5% of the kWh consumption is allocated towards cooling, and you may have seen, well, we didn't see much cooling there. We're going to dial that back to 2%. And then you can, just by clicking the redistribute button, you can redistribute that that kWh consumption to each of the other electricity consuming systems. So that's the general assumption of the whole building and the end use consumption, which gives us, the basis of consumption to make our savings projections. But I did want to call out also at this point the underlying, or the key assumptions tab, and make a few points here. You'll see on the energy cost per unit side, we have a value here for this building of 19 cents per kWh. That is that assumption is fed by EIA's database of average commercial retail rates for this type of a property served by the utility in this geography. But again, let's say you are privy. Again, this assumption is made without any access to building specific information, but the way that the app is structured, as you see, if you happen to be privy to site-specific information, let's say historic utility bills, and they say, well, actually, I've looked at the bills and it's actually, this customer's at 17 cents a kWh. Again, you can make that adjustment. You'll see we have some assumptions in for cost escalation on an average annual basis. And of course, back to the energy consumption tab comments, we have an assumption of the total annual consumption of kWh and CCF natural gas consumption. So again, you may be privy to the actual bills and say, well, actually it's not 558,000, it's 550,000. So these are, the concept here is, as you can see, you could really, and this is a theme actually the past couple of weeks we've been hearing more and more of, as we're all sort of working out of home, and many contractors or project developers have no access to the buildings that they've either had in their pipeline in developing proposals or seek to develop proposals. So this notion of a virtual audit or a virtual assessment is now coming front and center for firms on how can they do analytics on a building and try to keep some momentum on the project opportunities that they were advancing with a property owner. And this is one of those ways. So anyway, concept is you start with a set of assumptions, and if you happen to have access to real site-specific data, you can go to the Key Assumptions tab and sort of override those assumptions, and from there you'll see that the app will then take its next step. So once you accept the consumption data, we then move to the Energy Improvements tab. And again, recall back on the building information screen, we made an indication that in our project we had a LED lighting, a rooftop air conditioning unit, and a whole building EMS opportunity. And you'll see associated with each of these measures is an enable or a disable icon. So I'm going to start and enable the rooftop air conditioning improvement. And you'll see a set of data initially populates, and so let me walk through some of these underlying assumptions. So the first assumption is whether your project entails replacing the entire system or all of the units, or advance, which I'll speak to in a moment, would be a partial project. For example, let's say you're just being called to duty to replace a single failed unit of multiple. We'll deal with the all case first. So the first data point here you see is the existing energy efficiency rating of the existing equipment, and that is pre-populated as you see in EPIC, and the underlying assumption of that data point goes back to the year constructed of the building. So the way that we handle that is as follows, and it's a good opportunity for me to drill through to some of the tooltips that we have baked into the app, and just to share this logic. So throughout the app, there's various tooltips. If there are user questions, the user can just click on it and go to the sort of an FAQ knowledge database. So on the existing EER, we make one of two assumptions. If the building is greater than 25 years old, of course, we don't know at that point what the replacement cycle was, and what dates. So what EPIC makes is an assumption at that point that the equipment to be replaced, so the existing equipment, is 25 years old for purposes of establishing the energy efficiency rating baseline. If the building is less than 25 years old, then EPIC assumes that it's original equipment and that the equipment is the age of the building. In this case, if you recall, our building was constructed in 1984, so EPIC is assuming the equipment is 25 years old, and then the next core assumption is one of the underlying databases of EPIC is the ASHRAE, the historic ASHRAE 90.1 standards, and so we're doing a lookup there. What was the 90.1 standard in effect? In this case, 25 years ago, and the assumption is that the equipment, the existing equipment, is compliant with the 90.1 standard. So that is the basis for the existing EER. Of course, you may have access to the building. You may be doing a site visit, and maybe you're able to look at the exact model number and do a lookup. And if so, again, you could override that number, but that's the basis of the pre-populated data. Next piece of information is the new energy efficiency rating. We pre-populate that based on our energy efficiency project database, and we use the average of the high efficiency equipment rating in this particular category of equipment, in this case, rooftop air conditioning. But of course, the assumption is you're in the course of scoping a project and proposing on a project. So the assumption here is the user would know what they would want to enter. Let's say we're going to propose a unit with a 14 EER, and so the user can manage that input on a total capacity basis. Again, EPIC is making a calculation there based on a few of the building characteristics, the type of building, the size of the building, and the fact that the building is located in this address in Providence. Of course, again, back to the weather normalization, we will know at that point from the weather normalization calculations and the underlying heating degree day and cooling degree day data what the cooling need of the building is, and then we'll make a, there's an algorithm that defines the capacity on that basis. Installed cost, we also have a pretty substantial database of energy efficiency projects, and we will utilize the average installed cost for this type of measure in this geography. I should point out that this installed cost includes both the equipment cost and the labor cost. Unlike some of you on the development side may be familiar with tools like RS means, which typically would be equipment cost only. So I did want to mention to those of you on that side that may be, again, in a preliminary scenario prior to engaging with contractors to get quotes on actual equipment, our experience is this is a high value piece of data for that circumstance. And then the last piece of information is the effective useful life or estimated useful life of the equipment. That information is generally coming from third-party sources like DOE or EPA or state utility energy efficiency program guides, i.e. third-party programs that have established industry norm life ratings on this type of equipment. So at that point, the user would submit that measure. When I go back and just cover the case of the partial, let's say you were active on this project for the reason of, as I described earlier, replacing one unit of, say, 6 rooftop units. As you see, EPIC supports that. By accepting that, you'll go to a more detailed or advanced screen where you see here's your replacement unit. Let's say you're actually going to replace it with a 20-ton unit. You can put the particulars of the capacity, the old EER, your new EER. Maybe you have a manufacturer's rating of 17 years as opposed to 15, what have you. And of course, your pricing, hit submit, and then the system would support that level of analysis as well. You also see EPIC will support PTAC units and split systems, so that's generally the area in the air conditioning category. So as you see, once I submitted that or accepted it, EPIC turned that line item of air conditioning green or shaded it green, and you see the effective useful life, the calculation of the annual kWh savings, the reduction in peak demand, the installed cost, first year savings, lifetime savings, and some of the financial summary KPIs of simple payback and the savings to investment ratio. So on, let me speak to the savings side. So on the savings side, the first calculation that EPIC is making, which is generally consistent with those that you see in the state utility energy efficiency program formula or logic, is to define what the percent savings is over the current energy end use baseline that's attributable to that measure. And then, as you noted in the key assumptions area, again, we at that point have an assumption about the electric cost per unit and natural gas cost per unit, and that allows us at that point, based on the estimated useful life, so the assumption is the savings will persist over the useful life. And again, we have an assumption in each of these improvements for utility price escalation on an average annual basis over the life of that measure, as well as a savings degradation factor that's associated with each measure. And that results in a lifetime savings estimate. So that covers the air conditioning measure. Now let's say we do want to propose a whole building energy management system as well. You'll see by clicking on or enabling that measure, we go to its screen, and the methodology here is an estimate of the kWh savings percent, in this case of the whole building, which would be estimated at 9% kWh savings, and fuel savings of 18%. Again, this would be consistent with the methodology that we've utilized over the years for third-party technical reviews and consistent with utility incentive programs, but those are editable by the developer in the event that they have further data to turn the dials. Install cost, same logic as I mentioned earlier. Let's say in this case, the developer says, nope, it's not 97,000. We're going to propose 90,000. And at that point, they're happy with the UL. They can hit submit, and then you will see the second line item will shade green, and you begin to see in the upper right-hand corner this dynamic of the installed cost, the lifetime savings, and the net gain or net cost of a project will update in real time. So that's a tool that enables the user to do some quick scenario analysis. As a for instance, let's say they wanted to, the real core of the project, let's say, was air conditioning. If they turned off the EMS system, you see the project is now marginally net gain over the lifetime of the system. But let's say the opportunity, as we talked earlier, for lighting was at this building as well. You'll see by going into lighting, the electricity savings here, again, this would be 65% of the energy and use associated with the lighting. And an EUL, an install cost. You'll notice, those of you that are familiar with lighting projects are probably not surprised by this, but given the short payback period and the strong savings to investment ratio and the contribution of the savings, you see the net gain over the lifetime went from without lighting of $91,000 to with lighting of $377,000, so a substantial contribution. So in any case, you can see that the tool can enable you in that preliminary scoping mode to bring improvements in and out and to see the economic impacts. So with that, we'll move to the next decision of the, both the project developer, contractor, and the property owner is, how do we pay, right? So in this case, let's take a look at the funding scenarios tab. And here there are three funding options that the user can do some quick scenario modeling, starting with self-funding. So that's pretty straightforward, right? Meaning the property owner is going to write the check for $205,000. Their estimated savings over the lifetime of the project is $583K, or a pretty attractive net gain of $377,000. So the presumption is, if the property owner has the capital budget to afford that, they move on accordingly and probably don't really scope out a bank loan or PACE financing. On the other hand, let's say the property owner really likes the project, is sort of game to move forward, but they want to explore third-party financing options as they don't have $200K available in the capital budget. So then by clicking the bank loan, you'll see the screen changes, and three variables are really in play here. The assumption is the bank loan would require a owner contribution, i.e. down payment, of 20%. Again, that can be toggle, whatever those real numbers or proposed term sheet may be from the banker, but that's pretty usual. So then the system would calculate the amount of down payment, the install cost, and therefore the amount financed. The tool defaults the typical bank term to 5 years with a 5.5% interest rate. And you can see this chart over on the right would then speak to, on an annual basis, what the estimated savings are, the loan payments, and the yellow line item represents the annual net cash flow. And you'll also see in those upper right KPIs, the interest cost now appears, and that's factored into the into the net gain or the net cost calculation. Also below the chart of cash flows is a table of cash flows, and this is where we find a property owner generally likes to focus, which is to say, looking at the projected savings over the useful life of the project, what would the loan payments look like? What would the estimated annual cash flows be, and cumulative cash flows over the life of the project. It also gives you a tool. Let's say you may say, okay, well, I think I could get a 7-year term loan, and given today's environment, and I'm a great credit customer, I think I might be able to get a 5% interest rate. And as those changes are being made, you can see in the upper right again, if I went from 5 to 5.5, the calculations change in real time. So it gives the user an ability with their property owner to scope out, if they're in this third-party financing area, what is the ideal or the optimized metrics as it relates to down payment, term, and interest rate. Similar logic with PACE. I know a lot of you on today's call are familiar with our PACE program in Rhode Island. And I had made a remark in my opening points about this tool now being able to generate a real-time PACE project financing pro forma. And so this is quite powerful in that context. So let me share with you the logic here. Similar to the bank loan, there's an owner contribution assumption. Again, those of you that are experienced with PACE would know one of the benefits of PACE is the 100% financing, and the fact that no owner contribution is required. The tool will default the term length to the estimated useful life, longest estimated useful life of the improvements that are selected. And again, an interest rate that would be commensurate with current market experience. But again, the owner may want to play with that a bit in your proposal as well, and say, well, what if I did a 12-year term and rates are headed down? What if it was 6%? That kind of thing. And it gives the developer the opportunity to use this tool either on a real-time basis in front of a property owner, or perhaps in a minute I'll share with you how you can download a report or a proposal that would facilitate the creation of different scenarios that you may want to present to a property owner, maybe in a PDF fashion, to bring them through your analysis as the project developer on the optimized project improvements, as well as the optimized payment method, to the extent that the property owner wants to drive the conversation in that direction. So that gives you a general sense of the power of the project funding scenario analysis. And I'll move forward now to the project summary tab. And that is, as the name would imply, it's a simple summary of the energy improvements that were selected, what the key savings, unit savings, and finance impacts are, a brief summary of the estimated energy savings over the life of the project, a summary of the key energy savings metrics, which is to say, first year electric and natural gas and total savings, lifetime savings in units, and then similarly the first year and lifetime in dollar savings, which of course the property owner tends to gravitate towards that. Also included in these analytics are some other key financial metrics that, depending on the type of property owner that you are engaged with, you may generate some of these questions. For instance, a property owner that's really financially oriented, let's say you're, Michael mentioned in his opening remarks, say you're meeting with the CFO, and they may say, well, that's all well and good, this lifetime savings number over 15 years, but I mostly care about the present value of those lifetime savings because I'm the CFO. And again, in the key assumptions, one of the variables is a discount rate. We default to 5%, but then again, that can be overridden, and a CFO or a property owner can say, well, I would like you to use 4% or whatever. And then the system will, on a real-time basis, calculate the present value of those discounted savings. that kind of a customer, and particularly an investor owner of investment property real estate, commercial real estate, they're often keen to want to understand what is the estimated property value increase or asset value increase of such a project. And that's a calculation that takes the savings that are estimated in the first year over an assumed capitalization rate to define an estimated property value increase. Again, a financially oriented commercial property owner investor type would likely know their view of what the capitalization rate of their property would be, and that'd be something that this tool would allow some scenario modeling on as well. So with that, I'll go now to the downloading of the report. And again, let's say we're going to call this the RTU, high efficiency plus EMS plus LED self-fund scenario. We're going to save and download it. And what gets downloaded is a formatted summary report, what we call the EPIC report. And the concept here is that just in a few seconds, a PDF report will be prepared. And the idea here is that such report could be appended to your proposal to a property owner, or as I mentioned earlier, maybe you would want to download different scenarios. Maybe you want to download the self-fund scenario and the PACE financing scenario as a for instance, and put those two in front of your property owner for them to see what are the key financial metric differences between a PACE finance project and a project, the economics of paying upfront out of capital budget. So you'll see the PDF will come with a built-in linkable table of contents, and just share with you the key format here, which is similar to the data you just saw in the actual app, but it comes in a 5 to 7 page, depending on the level of measures and financing options. And it summarizes the building characteristics, the key cost summary, savings summary, the summary of the improvements, the key financial metrics that we just looked at, the underlying assumptions, namely the electricity and fuel cost drivers and the escalation assumptions. Again, you might be doing all of this analysis without being privy to any site-specific data or actual historic utility bill data. That's one of the powers of this tool. And then to disclose that to a property owner, and then they can maybe a next step they say, well, actually your cost assumption is higher than I'm actually paying, or lower, and then as you see in a matter of minutes, you could make those adjustments and resend such report. And then you have the summary metrics of the unit consumption, and again, how that consumption is allocated at the system end use level. You've got some disclosure of the key underlying assumptions, and then on a improvement by improvement level, you have a level of detail back to some of the inputs that we looked at a few moments ago, existing and replacement EER ratings as a for instance for the air conditioning improvement, etc. And then the total project savings. So the idea of this report, again, is to be either appended to a proposal, or maybe you're even in a pre-proposal phase where you are looking to spur on a conversation about the project economics, and trying to advance a conversation with a property owner on what the optimized project would be from your prospect's point of view. With that, I wanted to just run with this concept of the scenarios for a second. I want to open up a screen here. You'll see. So I had done this previously for this property, this 235 Plain Street office building property. And as you can see, I created sort of a half a dozen different scenarios. So I kept with that theme of the RTU and EMS. I did not include lighting in these, but I just wanted to share with you a perspective of the potential, practical uses. One of the areas where we see a lot of interest from the contracting and project development community is the ability to present to a property owner the economics associated with code compliant equipment and high efficiency equipment. And with that in mind, you can see I created these various scenarios. So in this case, this one, for instance, is a code compliant RTU system, whole building EMS, assuming the property owner would self-fund the project. And you can see sort of the summary analytics here. And then I would be able to compare that, let's say, to the high efficiency RTU unit, also self-fund. You see just at a very high level, the net gain of the code compliance is about $34K over the lifetime, and yet $94K with the high efficiency unit. So this is an example of the different ways this capability of on a real time, literally in minutes, capability to create different project scenarios and present the economic impact to a property owner, which in most cases you'll see the high efficiency units, although the pricing may be 10-20% higher, whatever that may be. Again, back to one of my earlier points, the property owner often is not seeing the other side of the equation. What are the impact of those savings over the lifetime of the system, and how would I consider that in my investment underwriting due diligence? And that's really what this tool is designed to do. So with that, I'll move to a couple other comments. Start to wrap up. The tool is a subscription-based tool, and the way that it is priced is as follows. The tool comes full-featured, regardless of what level a user may subscribe to, whether it be basic or premium. The real criteria that a user is making a determination on the plan, whether it be a basic or a premium plan, is the number of projects per month, the number of new projects per month that they have a need in their business to create. You can see the basic plan is aligned for those users where 5 projects on an average monthly basis would meet the need. For users that have higher project touches per month than that, let's say up to 10 projects per month, their subscription fee would be $259 per user versus $159 per user with the up to 5 or the basic plan. Larger accounts, we generally would engage with them on an enterprise basis, but the assumption is, generally speaking, the user starts either at a basic or a premium plan level, and moreover, each of those plans comes with a risk-free 14-day free trial period. And so that would be one of the opportunities available to you after today's program would be to take advantage of that 14-day free trial if in fact this strikes you as adding value to your current process or a fit for your current business. The tool is priced in mind with even small to mid-size contracting or project development businesses, meaning it's priced to help ensure you earn a return on investment. On the website, we actually have a return on investment calculator which allows for a quick analysis as follows. Let's assume you typically do 1 to 5 projects on an average monthly basis, and your average project amount is $75,000. Assuming a 25% profit margin to the business, you'll see the table here in the bottom right is the impact of EPIC in just winning 1 additional project per year. Based on those metrics, you would see your subscription fee would be a little less than $2,000 a year, and the additional profit multiple would be almost 10x, or $17,000 to the firm. So it's priced with that in mind to be affordable and to be a low bar in terms of return on investment. So in sum, if you're coming at this from the HVAC contracting workflows and point of view, generally we see the tool being used by HVAC contractors to append that EPIC report to their standard pricing and project proposal. As I mentioned earlier, helping to ensure the property owner has the information to make an expedited and what they feel is a fully informed due diligence decision. Namely, it's to help to get the property owner's vision beyond, as we mentioned earlier, just the pain of the cost, and help them with the visibility to see the saving side of the equation, and in many cases actually present to them, this transformation of an unwelcome capital expense in their mind to a compelling investment opportunity. Again, that point I was making earlier of the quick ability to create a scenario of equipment meeting code versus high efficiency, and what the resulting economics are, is a powerful way to present and engage such a discussion with a property owner, and obviously would make your proposal stand out from the crowd, which is a key value point. On the project development side, as I mentioned in my opening remarks, we often, when collaborating with project development firms, hear that frustration of, the property owner is not yet far enough along in their thinking or their commitment to the project to make a financial investment, i.e., say 10 to 20 grand commitment to do, say, a level 2 energy audit. And that poses various limitations, and it's been tough to collect enough information from a property owner who's in that mindset to utilize, say, traditional whole building energy modeling tools, or even in-house, sophisticated spreadsheet analysis that many of the developers have developed and refined over the years. And that's where we're finding an attraction of EPIC, the so-called missing link, right? To come into that preliminary first look scenario, even as we're all being stressed by the coronavirus shutdowns, to different levels in our business. Even the point I made earlier on, how might we be able to do a remote analysis or a virtual audit, so to speak, given we might not have any access to go on premise to the building now or anytime soon, yet we would like to have a way to advance this conversation with a property owner. And so that's where we see EPIC fitting. And obviously, the type of property owner that would be considering a comprehensive energy efficiency project is typically the kind of owner that has a financial orientation, and they're looking at this from a investment key performance financial metric lens. The other area that we see the project development community responding favorably to the functionality and benefits of EPIC is in the quality assurance or quality control side of their business. And this is an area where at SRS, again, we've been for a decade now doing third-party energy efficiency project technical reviews on behalf of PACE programs around the country. And we've utilized this software internally for many, many years, although it's just being rolled out in this app form, in the form of this Epic tool. It's a set of tools we've used internally for QA/QC, plausibility checks, and the like. So envision, you're working on a project. You may have different methods going on, some spreadsheet, some other software system-based, and you want to make sure that the consumption and energy end use estimates are consistent across that workflow. Maybe you're working with some third parties, and you want to make sure you have a QA filter on that. And as I mentioned earlier, maybe you don't have any visibility at that point in your preliminary process to project implementation costs. All these are benefits that Epic can add in that context. So I'll wrap up with a few suggested next steps. Those of you that are game to take advantage of the 14-day free trial, you can visit our website at srsworks.com and follow the free trial link. Those of you that perhaps have your wheels turning based on some of the applications I just shared with you, and maybe would like to schedule a one-on-one demonstration of this with yourself and perhaps some other colleagues within your office, you can feel free to do so. I think many of you are already familiar with Bill Constantino, who's our Rhode Island PACE program director. And by tomorrow, close of business, we'll send a follow-on email from Bill to each of you. And if you'd like to take up that opportunity, you can feel free to respond to that email and arrange that as well. So with that, I will move to wrap up and just say thank you again for making the time to attend the webinar this morning. We will make a follow-on email to you by close of business tomorrow. If there's any questions or comments that weren't fully addressed in my presentation today, you can feel free to follow up with us on email, and we'll pick it up via that channel. So thank you again. Stay healthy and enjoy the rest of the week. Best of luck.